For example 2 of function composition, we want to look at functions defined by rules. So these are typically how functions are shown in math classes, where we have f of x equals some rule, and then to find out the output, you just kind of follow that rule, whatever number you get, you're done with. So for instance, here if we wanted to find f of 3, we would of course just plug in 3, and we'd end up getting 6 plus 1, which is 7. So f of 3 is equal to 7. Right, we can do the same thing with our function composition here. So same rules apply. F of g of 2 is still f, g on the inside of 2. So I'm going to plug 2 into g of f. Right, so this is going to be f of, 2 squared. Right, I can always working, just like we're used to working with rule operations, is always inside to outside when it comes to parentheses. Same thing with functions. These act as you want to do the stuff on the inside first. So this is really f of 4. Well, f of 4 gives us 2 times 4 plus 1. Now that's 8, 9, so that's 9 right there. Notably here, what's interesting about composition is that you don't always get the same number working one direction or the other direction. So when you multiply numbers, if you do 3 times 5 or 5 times 3, you get 15 either way. Right? Well, let's show that on this piece of paper. You get 15 either way. That's not true of function composition. When you reverse function composition, you don't always get the same number. So let's do this example I set up here. So here above, we just did f composed with g of 2, and we got the number 9. So now we're going to go g composed with f of 2. Right? Well, that's going to be g of f of 2 is 2x plus 1. So it's going to be 2 times 2 plus 1. Well, that's going to be g of, if I do this, it's going to be 5. And then g is the input squared, so it's going to be 5 squared. That's 25, which is not 9. So as I was describing here, right, when you switch the order, when f becomes g and g becomes f, right, you don't get the same thing, which is unlike what happens when you do something like multiplication or addition. Right, like I said, you can compose with the function itself. So here we have g of g, so g of 3, which is the same thing as g of 3 squared. 3 squared is 9. So now we have g of g, so now we have 9 squared. And that's the same thing as 81. Right, so we can just work it out like we have done. So let's do our last one here, and then we can talk about the tricky stuff, which is what happens when you plug in a variable instead of just plugging in a number. So f of 5, right, it's going to be f composed with 2 times 5 plus 1, which is equal to f of, 10 plus 1 is 11, right, and now f of 11 is 2 times 11 plus 1. Well, 2 times 11 is 22 plus 1 is 23. So f of 5 is 23. Right, and you could go on doing this. So let's say you have f of g of like 18 numbers you wanted to get, right? Maybe you wanted f of g of 1, f of g of 2, f of g of 3, f of g of 4. That'd be fine. You could just do that again and again and again. But it might be nice to just do it at once and then maybe have a simpler thing to do instead of just doing this like kind of long process where you kind of have to find the number in along the way. There's kind of, when you have 2 rules for functions, you can just find a third rule that might be a little more complicated, but you can go straight to it. So when you have f of g of x here, right, that means I have f of x squared, right, because g of x spits out x squared. Right, and now we're replacing x squared with the input here. Right, and so we're replacing x with x squared, and so we're going to get 2 times x squared plus 1. And that's it. That's what f of g of x is. So if we go back to this first example, we had f of g of 2 and we got 9. So let's just double check that works. Right, so we had f of g of 2. Right, and what we could do is instead of plugging it into here and going through there, we could instead just go, well, that's going to be 2 times 2 squared, because that's where my x goes, plus 1. While 2 squared is 4, 4 times 2 is 8, 8 plus 1 is 9, and we got the exact same thing. No surprise, math worked out in this case, right? When we solved it, either going through kind of a longer way or shortcutting with this formula we made, we got to the same number. Right? So we can also compose the other way, just for practice here. So we have g composed with f of x, right? F of x is of course equal to 2x plus 1. And then g takes x and then squares it. So I'm just going to take this whole inside thing, 2x plus 1, I'm going to make sure I square the whole thing. And so here, after I square the whole thing, either I'm going to leave it like this or I'm going to expand out the square. Right? Remember that this is 2x plus 1 times 2x plus 1, and so when you expand it out, you're going to get 4x squared plus 4x plus 1. And remember that middle term shows up. Alright, really, really important that we're not forgetting that. Alright, and that's how kind of function composition works when you have a set of rules for functions instead of just a set of tables for functions.